We're going to be talking about CSP and hybrid identity today. So it's a topic that I'm very excited to share with you guys. So my name is Naveen Chand. I'm a product manager. I work on GCP identity. Today I'll be joined with my esteemed colleague Breno, who's an engineer working on GCP identity as well. We introduced Anthos 2 days ago, which is the latest innovation in hybrid and multi-cloud that allows you to modernize your applications, automate policy, provide security at scale, and have your applications run anywhere, either on-premise or in any cloud. Now, at the center of a lot of these scenarios is really identity. In order to be able to achieve these true hybrid, cross-cloud, cross-platform type of capabilities, the strong notion of identity is required both for policy as well as seamless access across these different systems. And so in today's talk, we'll be walking through a deep dive in a couple of specific use cases around hybrid identity, starting with GCP, hybrid identity, and beyond Corp. We'll then talk a little bit about authentication inside of Kubernetes, getting into things like workload identity, on how you can actually go start using workloads that exist in different systems, get access across without having to do things like key exchanges or downloading specific user keys or service keys. And the final thing that we'll talk about today is really around Istoo identity. So to tee it up, GCP and hybrid identity, along with Beyond Corp. Now the first thing is really, when working in a hybrid environment, you need to get your users to get access to GCP. And so after you've created your organization, one of the first things to do is to go and start figuring out how to grant your developers, the rest of the folks that actually need access to the environment, permissions. And so to grant access, we use something called Google Cloud Identity, which is a Google service that allows customers to create and manage users, as well as groups, in order to grant them access to cloud resources. Now, in addition to granting access to GCP, Google Cloud Identity is also a standalone offering. It has IDaaS capabilities that allows it to do things like robust lifecycle management, device policies, provisioning of users across a multitude of different applications. If your identities are actually reside in an on-prem, just like this example shows, you can synchronize it using a tool called Google Cloud Directory Synchronization, or GCDS for short. And this tool allows you to select the specific users using LDAP across either an LDAP filter to select which set of users you want to bring in, or select the set of OUs that you have in order to pull those identities in. In order to configure single sign-on, you can use SAML, either in this case using an ADFS instance or any really federation token broker that allows you to take identities from your on-prem system, present a SAML assertion that can be used in order to grant them single sign-on into GCP. If your company happens to use one of these other identity platforms, many of them have capabilities built in that allow you to do things like provision users and configure the single sign-on directly with GCP already. Next, we're going to talk a little bit about Beyond Corp. Now, starting in 2011, Google introduced a new approach to how to do access management, which was called Beyond Corp Security, the Beyond Corp Security Model. It's a zero trust security model. And what that means is you don't rely on the permissions or specific network configurations or making sure somebody has to reside on your corporate network in order to gain access, but instead it verifies properties of the requester, making sure that this requester has access and permissions to the specific resources that they're gaining access. So it shifts the focus from using network perimeter to individual users and devices, and using those in order to decide whether or not somebody should gain access. And this allows employees to work seamlessly regardless of where they're located. So we're going to spend a couple of minutes and look a little bit closer into Beyond Corp and how it can be used in a hybrid environment. Before we get there, though, just going a little deeper into Beyond Corp, for Beyond Corp, there's several different components that are needed in order to be able to make up the solution. One is a notion of strong user identity, and while it doesn't require you to use phishing-resistant technology, it definitely works very well with that. So you can use notions like security keys in order to make sure that the requester that's coming in is actually accessing the location that they need. It also leverages context information about the request. So things like where the request is originating from, And in addition, looks at things like device posture to see what type of device is this request actually coming from as well. Using those two types of information, it pulls it into a centralized policy engine that allows both IT teams to go define these types of policies that says only devices that have the following security postures and these specific classes of users can get access to this resource. And then uses a centralized enforcement point in order to be able to ensure that this type of access is consistently administered, regardless of where a person's coming in from. So Google Cloud provides a solution for the Beyond Corp product, and it's comprised of several different products inside of Google. One of which is Cloud Identity, that allows you to take care of the identity as well as the context information in terms of what device is this request actually coming in from. There's another component around a rules engine, and that's done through Access Context Manager that allows you to go and look at information around kind of origination of the request, device posture, in order to make that authentication and authorization decision. We also use VPC security service controls that improve your ability to mitigate the risk of data exfiltration from Google managed services. Things like cloud storage, BigQuery. You can actually do a boundary around all these services to ensure that all your data retains within those walls. It also uses IAM, which is Identity and Access Management, that allows you to specify granular controls on resources to decide whether or not a specific user should have access to that resource. And the final piece is really Cloud IAP. Now, Cloud IAP, or Identity Aware Proxy, is a GCP service that provides off-the-shelf authentication and authorization for applications that are deployed on GCP. It is also the starting point for many customers to retire their legacy VPNs and use Google's context-aware access story. But while this works great for scenarios that exist on Google Fabric, the reality is many customers have applications that actually run either in an on-prem environment or in another cloud. So IAP also now supports the ability to protect your workloads no matter where they're located. Numerous customers are now routing traffic that actually goes through Google's front ends, leverages IAP, and then forwards the encrypted traffic back to their applications, no matter where that application is. And the best part is there are no changes required to the application. It all happens right in front of it, adding a layer of protection. So we're going to walk through this in a little bit more detail. When a user actually connects in, one of the things that happens is their device posture and device information is captured and continuously updated in one of the databases. When a request comes into the system, GCLB provides network layer protection. So it can do things like protect it against DDoS attacks, provides TLS termination, and also manages certificates and allows you to configure things like IP block lists. The Identity Aware Proxy uses the user identity as well as device information in order to be able to make access decisions. In this case, you'll see the IAP on-prem connector, which is the component that allows you, it's an open source tool that allows you to connect to an on-prem backend resource. One of the things that needs to be done is for that on-prem application, need to configure the network policy so that only requests that originate through the IAP front-end system will be able to get access in order to truly deploy this model end-to-end. Once that's configured, the Beyond Corp model works completely for these scenarios. So that was the first section, talking a little bit about how you can use GCP in a hybrid environment where your users are either configured in an external identity source on-prem or coming from an external IDaaS system. Talked a little bit about Beyond Corp. Now we're going to switch into Kubernetes, and then we'll talk about how you can configure authentication and authorization into Kubernetes clusters using your existing enterprise infrastructure. For that, I'll switch over to my colleague, Breno.
Thank you, Naveen. So in this section, we will be looking into how to authenticate into the Kubernetes control plane for cluster management activities. So we'll focus on the usage of the Kubernetes API through the standard command line interface, or CLI for short, which is called CubeCaudill. And the same principles apply to other means of interacting with the control plane in Kubernetes. For instance, if you use any of the controller UIs. So in this scenario that we're going to look into here, we have Janine as a cloud engineer, and she works for a company called Zotkicks. She just finished creating their first Kubernetes cluster. As Janine went through the steps to create the cluster, those steps gave her admin privilege, which is natural because she just created the cluster. But it's based on secrets that are stored in a kubeconfig file, typically. That's the outcome of creating a Kubernetes cluster through most of the procedures. But Zotkicks security policies outline a set of requirements for access to production assets. And these requirements are not met by secrets stored in configuration files in administrators' laptops and other devices. So we need to find a different solution that is enterprise compatible and compatible with security posture of most enterprise environments. So indeed, in most enterprise environments, integrating with the SSO infrastructure is required to manage the production workloads. So this involves two steps, effectively. One is to connect the authentication and the credential management to the SSO system. And the other is to configure permissions based on the centrally managed groups. So we'll look into each of these steps in detail. Well, first, what is available in Kubernetes today? So Kubernetes supports several mechanisms to authenticate into a cluster. But for integration with SSO systems, Kubernetes supports in particular OpenID Connect, which also known as OIDC. And Active Directory Federation Services, or ADFS for short, is a commonly deployed enterprise system, part of the Active Directory set of services, and it implements an OpenID Connect provider, identity provider, or IDP. So this provides a means for us to enable enterprise single sign-on into a cluster. I'm assuming in this talk that we're using ADFS. We're going to go into some configuration details here, but many other enterprise SSO solutions, such as Google Cloud Identity, the Google Cloud Identity Platform, Azure AD, Okta, all support OIDC. So now we're going to show a demo on how to register OIDC client for ADFS. So here we have the panel for Active Directory management. We have a handy set of notes, and we have a PowerShell. I hope it looks better from there. So first I add an application group, and I'm giving it a name. Is it good, visible from outside? And I will make it a server application type. I need to choose a client identifier that is a little more easily recalled, because the one that gets generated is random, so it just makes painful to copy and paste. But I'll copy it in here and remember it as my client ID. Next, I need to have a register redirect URL. I should first choose a port that is widely available in my enterprise environment, and then I can register a URL that points to that port. The reason is that we need a place to redirect the token after the authentication to the user's workstation. And here we copy also the client secret that gets auto-generated when we enable secret-based authentication. So I finished creating an OpenID client in ADFS, but now I needed to configure a token groups rule, which allow me to share groups information from Active Directory with the Kubernetes cluster, so we can do role-based access control. So I have to give it some descriptive information so I can remember it. But the important thing here is also that I need to authorize later to grant us essentially permissions for IDFS to share that information to the specific Kubernetes client that I registered in the first step. So I created the rule. Now I'm actually saying what I'm going to populate it with, what is going to be propagated by that rule. And what I will configure this is to use LDAP groups. It's called the token groups. So I'm using token groups qualified by long domain name, which gives the greatest security because you can't have collisions that way. And I'm naming the, outputting the token as groups. That's going to be the claim name in the token. And I'm remembering all of this information because I'm going to have to configure my client as well as the API server to be able to understand how to process the token information. So finally, now that I finished creating the configuration of the client and of how to share the group's claims, I need to grant authorization to the client that I created to receive groups information. So that's the last command that I'm going to run in the Windows PowerShell as an administrator. And we are done with this first step. And if you have a different IDP, Oct or something, Cloud Identity Platform, Google Cloud Identity, you're going to have a different set of steps to configure the identity provider. But most of the subsequent steps in this conversation here will be generic for any provider. So we have now some handy notes that we took during our client registration with the parameters for the OpenID Connect client that we registered. But the CubeCaudill CLI, the command line interface, also needs those parameters to integrate with the IDP. But in addition to the information about the client, basically the OIDC client, CubeCaudill also needs some information about the provider itself, such as where is the provider? So we'll show how to get that information from ADFS. Okay, so here, there are two pieces of information that I need about the provider itself for my CubeCaudill configuration. One is, where's the provider? So I'm going to start I'm here at the ADFS server, and it has the host information, has the domain information, so that gives me the domain part of this URL. And next, I'm going to look into the endpoint configuration for ADFS, because ADFS has many endpoints that serve different properties. I look at the OpenID Connect endpoints, and what is important is there is something that starts with .well-known. The part of the path before that is where the ADFS instance is. So I got that section of the path. It's very typically just ADFS. And now I want to get the certificate. So I'm looking into the certificate that the ADFS server uses because the Kubernetes cluster is not part of my domain and it doesn't know the intermediate certificates that I have deployed in my services, such as ADFS. So I'm going through the certificate tool and I am going to export the intermediate certificate that is used by the ADFS server. So I just used the export wizard, and I had chosen a file name. So I'm going to use that. And we are finished with the parameters from the issuer. Okay, so now we have the OIDC client parameters, and we have the issuer parameters. Now we go to the API server. We need to configure the API server to actually accept sign-ins from this OIDC client that we created. So this involves restarting the API server with a set of flags that enable OIDC authentication. So this I had from my handy notes that I took while I did the previous two demos. And this is showing to how I can configure the flags with those parameters. And if I restart the API server with those parameters, it will be able to accept OIDC authentication. Now we are finally ready to prepare CubeCaudill to authenticate to the cluster. And CubeCaudill, remember, it needed the OIDC client parameters that we registered with ADFS. It needed some server parameters that we got from the ADFS configuration itself. But it also needs some parameters from the cluster so it knows how to talk to it. Okay, so that's the last set of parameters that we need to finish this. So recall that right after Janine created the cluster, she had a usable configuration that gave her admin privileges in the cluster. So that configuration actually has all the cluster parameters that we need. So we are going to go look into that file, the kubeconfig file that was initially created, to get those parameters so that we can package all of this in a single file that will make it much easier for all the other administrators as well as the other users, developers in the cluster to be able to authenticate. So let's see how we can package all this metadata. So we have created a plugin to facilitate users to sign in. Today, to get access to it, you need to sign in for the GKE on-prem offering. But if you, in the future, we plan to make it more widely available. So once you download this plugin, you make it executable. And if you move it to a path, a location in your path, it will be available for CubeCaudill. So now I have collected in this file all the parameters from the 3 steps that I went before. And I configured them as a single command, which is CubeCaudill. OIDC is the name of our plugin that we just installed. And client config is the name of the parameter. Once we run, we need a couple of the parameters that I explained from the cluster itself. So now I opened that early kubeconfig file, and I found the server name. Okay? And I'm back to that file. The server location, the server name, and I need the server certificate authority. So I gave it a name, and I'm going to export from this was the certificate that was embedded in the original CubeCaudill config file, and I'm going to basically base64 decode it into a certificate file. So now I have everything ready. See, I have a properly formatted certificate stored. I have all the parameters. I can run that command. And I have a file. And so that is completely configured with client information, OIDC issuer information, and cluster information that CubeCaudill needs to be able to authenticate. So this was a lot of steps. You definitely don't want more than one administrator to have to go through this. So that's why we created this plugin. This plugin wraps all the parameters in one easy file, and now you can distribute this file to all the users in your organization. Okay? So let's see how we can actually use this file to enable all users in the organization to easily sign in with OpenID Connect. Okay, and so we are again using the same plugin, but now the login command. I chose a username for myself. I passed the config file that the administrator sent to me, and I chose a kubeconfig name where I store my kubeconfig information. So I'm signing in using the ADFS sign-in page. That's it. That's the user experience, and they are ready to go. So now you have everything is stored in this kubeconfig file. I'm going to set up as my environment variable, so I can now just start performing operations with the cluster, and I'm authenticated using single sign-on and leveraging Kubernetes authorization. So a lot of steps for the first administrator, extremely easy for other administrator or users later. Once that file is packed, you just have to run, that's all. Okay, let's look a little more into how Kubernetes RBAC works. Because we figured out how to authenticate, now how do we grant privileges in the cluster? So Zoctix, again, bringing back to their perspective, wants to segment privileges within the cluster. So one situation could be that they require a strict separation between production and development workloads. So Kubernetes allows you to compartmentalize permissions in this way through namespaces. And administrators can delegate permissions to a namespace. Permissions can be attached to a role, and there are two types of roles in Kubernetes RBAC. One is a role with cluster-wide scope, that's called a cluster role, and you want a role that has namespace-wide scope, and that's just called role. Roles can be granted to users and groups using bindings, okay? So a cluster role binding binds a cluster role to a user or a group, and the binding has a scope across a cluster-wide. A role binding, on the other hand, can bind either a cluster role or a role to a user or a group, but the binding has namespace scope. In the next demo, we'll show how a Zotkix administrator can use bindings to grant roles to users and groups. So I will now show a demo of how to set up the Kubernetes RBAC. I can see my AD, I have two users. One is Breno. And if you look at the properties, he is part of a group called cluster admin, okay? But we also have another user called unprivileged. And as we would expect, he is not a member of any group except domain users, okay? So I am logged in to CubeCaudill as myself using the plugin as before, and I'm gonna get cluster roles for this cluster. There's a bunch of them, and I see one called cluster admin that looks suggestive. So let's find more about that cluster role. So I am going to inspect that cluster role called cluster admin, and I see that it is a cluster role. The name is cluster admin, and it is granted a lot of privileges, okay? It can do every operation on every resource, on every API group in the Kubernetes API. Great. Who can actually exercise that cluster role? Well, I see also a role binding called cluster admin. Maybe that's the one I'm looking for. Let's look at this cluster admin role binding. Okay, it is a cluster role binding. The name is cluster admin, and it refers to the cluster role cluster admin that I had before. So it looks all promising, but the subject is a system object. That doesn't sound like the right cluster role. I would expect users, groups coming from AD in that setting. So I'm going back to my list of role bindings, and I found something else called cluster manager. Is that the right one? Let's look at what the cluster manager has. It looks very similar, but the main difference is that the subject is the group called cluster admin coming from the SSO environment. So that's indeed the binding that is granting me privileges to perform all these operations, okay? Now I'm gonna try and do the same as the unprivileged user, okay? And if I remount this operation, I can see that instead of looking at the cluster roles, I'm getting an error that the user, with the long name qualified there, cannot list resources cluster roles, okay? Because they are not a part of the cluster admin group, and therefore they are not bound to the cluster manager role in the cluster. Now we talked quite a bit about user authentication. I will talk about workload identity now. So workload identity in Kubernetes, there is a pre-built-in system for workload identity in Kubernetes. When we use the Kubernetes API, and this form of Kubernetes identity is called a service account, and it's created in a namespace. So Kubernetes service accounts may be granted permissions either via cluster role bindings or role bindings, just as users and groups. So in this example, I'm showing here how Jenkins CICD workload can be granted permission to modify all pods in a cluster. It also shows how the same permission can be granted. So if you look here, can I see the, I don't see my, oh well, sorry. I don't see the pointer, so I'm just going to point it directly. You have a cluster role called pod updater, which is given permissions to modify pods in the cluster.
Did it disappear? Is it on this one?
And it is, we have a cluster role binding that binds this privilege to a service account called CICD, which is your continuous deployment tool. And so naturally, the continuous deployment tool needs to update jobs in the cluster. And so the granting here refers to the cluster role pod updater. So this allows a workload that's running in the cluster with this service identity, which runs in the production namespace and with name CICD to modify all pods in the cluster. There is a separate role binding here that gives to the dev team the ability to exercise also this pod updater rule, but only in the namespace development. And so if you have a production job, they will not be able to modify it. We now have support for workload identity in GKE to directly exercise privileges in GCP IAM. So that makes it much easier to secure access to your GCP resources because you no longer need to download and manage GCP service accounts in GKE. Instead, you can, with workload identity, the provision of credentials for GKE services can be fully managed. So if you look at the parallel here, in Kubernetes RBAC, if you wanted to grant privileges, you create a cluster role, and you create cluster role bindings where you grant those roles privileges to specific users or groups or service accounts. In GCP IAM RBAC, you similarly you have a service account, GCP service account, and what you do is you grant this service account access to some properties in your project. So here, I'm granting this GCP service account an editor role in the project. Then you can exercise that role from a Kubernetes workload by adding a policy binding that mentions a workload identity in GKE, okay? So that's what this expression is describing here. If you recall from the example that we gave, the namespace production and the service account CICD represented my continuous deployment tool. So with this configuration, you don't need to download a key into your GKE deployed tool. It can directly access GCP. Okay, and this, courtesy to our friends in the GKE team, I have a demonstration of how this works. First, we are creating a works cluster. There is a flag called identity namespace that tells us that you should enable the workload identity feature in the cluster. So we're looking at the configuration here. I have an app called GCS server. And it has an annotation which refers to a GCP service account. So that tells our metadata service to how to allow the workload identity to get tokens to talk to GCP. And this all happens transparently with no changes to the application. all the provision of credentials is using the infrastructure of GK. So just for reference, we have the namespace and service account, a workload identity service account there. We are creating that GCP service account we referred to in the annotation. And we are seeing that the application that we constructed is now running, is deployed. We want to grant the binding that I talked about, where we give the Kubernetes service account the ability to impersonate the GCP service account to exercise that role. Whoops, something is not working. What could possibly go wrong? We forgot to grant actually privileges to our GCP service account that we just created, okay? So it is successfully impersonating the GCP service account, but the GCP service account has no privileges. So we can fix that. In a minute, you'll see how to fix that. Okay. The error is access denied. So we are indeed, you see, you mentioned the GCP service account. So the error was, so now we add the permission. See, that's echo. And we gave reader privileges to our GCP service account permission. And now the job is able to perform its operations correctly, fetch the results, and display them. And this is showing that this is a multi-cluster feature. You can enable the same identity in the same role be used by multiple clusters. Okay, and so we are deploying the server in a different. You can see East can access, and so can West. All right, they both can access your GCS resource. And however, if you delete that echo, the echo on the service account, you can see that the application no longer can access the same resource. And you go back to that scenario where you don't have privilege. Okay, so that finishes our demonstration of workload identity on Kubernetes. And now I'm going to give you an overview of identity authentication in a hybrid environment. So Istoo is an open source mesh that layers transparently on existing distributed services, and is also a platform, including APIs that let integrate with any logging, telemetry, or policy system. So why should we consider using Istoo in my hybrid environment? So Istoo makes it easy to create a network of deployed services with load balancing, service-to-service authentication, monitoring, and more, with few or no code changes in service code. And it also can be used to deliver secure service-to-service communication in a cluster with a strong identity-based authentication and authorization based on mutual TLS. And Google is a major contributor to the Istoo development and architecture. So it means that by using Istoo, you take advantage of some of the best practices and strategies for microservice mesh management. So to begin, you add Istoo support to services by deploying a sidecar proxy throughout your environment. And this sidecar proxy intercepts all network communication between the microservices. One then can configure and manage Istoo through its control plane functionality. So it allows hotkey in this case to distribute policy throughout the mesh, as well as telemetry configuration, audit policy, network accessibility rules, and so on. And configuration is consumed by all these Envoy proxies, both an ingress proxy if present, as well as the sidecar proxies. And the policy is enforced by the infrastructure. So in particular, why you should use Istoo security? Because it delivers authentication, authorization, and audit as part of the platform. So you don't need to burden your application developers with getting that right. And in addition, you get consistent application of those policies, so much easier to complete compliance activities within your environment. Okay, so let's give an example scenario where Zotkix is trying to use Istoo to provide access management to their on-premises applications. In this example, it's deployed in the GKE on-prem cluster, in particular Kubernetes cluster, but Istoo can also be used to protect workloads in more traditional on-premise data centers that are not based on Kubernetes. So here, when the Corp user is authenticated using credentials from the Corp environment, and they make a request, let's say to the Zotkix HR application, the ingress proxy will terminate the TLS connection and will enforce that the request includes user credentials. Later, as the request travels down the stack, you can have policy being applied at every hop. So, for instance, if you accessing a method that requires administrative privileges, the sidecar envoy can require that you have those privileges because you belong to a particular privileged group that has the ability to perform that operation. And in between hops, Istoo can leverage both the initial requesting user identity as well as the peer identity to perform authorization. Here we see a scenario where the employee is accessing from an overseas location. Okay, so in this scenario, Zotkix decided to use the Identity Aware Proxy, IAP, to take advantage of Google's fast network, globe spanning network. So many of our customers actually use IAP to route both traffic to their cloud applications as well as on-premises applications because of the advantage of the Google network connectivity. And by using IAP in addition, you get access to the context-aware authorization rules that IAP provides. For instance, you can configure that some operations require second-factor authentication or that the device is in a good state. Now let's look at how Zotkix can use the same architecture to protect their cloud apps. They have extended the identity system to GCP by using Cloud Identity. By leveraging the Identity Aware Proxy, they have authentication authorization at ingress, which simplifies the management for the applications. And here in this scenario, we show that this can be used to protect a legacy application, such as a database VM running in GCP. Employees also can have access to their GKE apps controlled this way. Again, similar, consistent view between the on-premise setting and the cloud setting by leveraging Istoo and IAP. In addition to protecting employee-based authentication, you can use this infrastructure to protect your consumer-oriented applications, the same architecture. And one of the advantages here is that authentication, authorization, and audit, they permeate the entire service stack, which reduces trust between systems. You don't need to trust the assertion of the user identity from the front end in the back end. You can remove this amount of service-to-service trust, which facilitates compliance against requirements, audit requirements, and it also just reduces insider risk. Another feature of this architecture is that it has a strong sense of peer identity. By using mutual TLS, you can have strong assurances about the peer that is connecting. So here in the Cases app backend, have a very strong confidence that the request indeed comes from its front end. So finally, we go back to what we talked about earlier with workload identity. You can enable workload identity in GKE and now have a fully managed credentials for your workloads where you can directly grant access to IAM to your workload identity. And you also make it much easier and secure to consume any GCP services such as Cloud Store or Stackdriver from Metrics. In this scenario, Stackdriver is providing the metrics telemetry infrastructure for Istoo. So tying it together, we can see that in a hybrid environment, Zoctix can leverage both open source Istoo architecture and Google managed services such as IAP and Stackdriver in a well-integrated environment that delivers consistent, transparent, and auditable policy enforcement. And in addition, through the integration of workload identity with IAM, Zoctix can seamlessly consume GCP services from their GK apps with improved security and eliminating the need to manage credentials. So let's recap. Summing up, we have seen that CSP and GCP provide robust capabilities to help you easily connect to your existing identity solutions. These capabilities enable you to uniformly manage hybrid applications with GKE and Istoo, and they allow you to easily secure your hybrid applications, your hybrid environment. And you can make your applications available anywhere securely by leveraging beyond Corp technology.